Ariane 6. Ariane 6, French,
Ariane 6.
is a European expendable launch system, or expendable launch vehicle, ELV, developed for the European Space Agency, ESA, and CNES, French,
Centre National d'Études Spatiales.
literal translation, National Center for Space Studies, the French National Space Agency, and manufactured by a consortium of European companies, led by the prime contractor ArianeGroup, formerly Airbus Safran Launchers. As part of the Ariane rocket family, it is operated by Arianespace SA, replacing the Ariane 5 heavy-lift space launch vehicle, HLV. The project's primary contributors were France, 55.3%, Germany, 21%, and Italy, 7.6%, with the remaining work distributed among 10 other participating countries. This two-stage to-orbit, TSTO, or two-stage rocket utilizes liquid hydrogen, LH2, and liquid oxygen, sometimes abbreviated as LOX or LOXygen, so-called hydrolox engines. The first stage features an upgraded Vulcain rocket engine from Ariane 5 launch vehicle, while the second uses the Vinci restartable, cryogenic, liquid propellant rocket engine, designed specifically for this rocket. The Ariane 62 variant uses two P120C solid rocket boosters, while Ariane 64 uses 4. The designation, P120C, reflects key characteristics of the motor. P stands for poudre, French for powder, referencing its solid propellant. 120 denotes the original target of 120 metric tons, 264,554.7 pounds, of propellant, later increased to nearly 142 metric tons, 313,056.4 pounds, and C signifies its common use across multiple launch systems. The P120C booster is shared with Europe's other launch vehicle, and is an improved version of the P80FW solid fuel rocket motor used on the original Vega expendable small-lift launch vehicle. Selected in December 2014 over an all-solid fuel alternative, Ariane 6 was initially planned for a 2020 debut. However, the program faced delays, with the first launch eventually taking place on July 9, 2024. While the rocket successfully launched, the mission experienced a partial failure when the upper stage malfunctioned and was not able to complete its final deorbit burn. The second launch was therefore postponed to March 6, 2025, successfully delivering its first commercial payload to orbit, the
Composante spatiale optique 3, CSO3.
English, Optical Space Component 3, reconnaissance satellite. Ariane 6 was designed to have launch costs and increase annual launch capacity from 7 to 11 missions compared to its predecessor. As of 2025, neither target has been achieved. The program has been subject to criticism over high costs and lack of reusability versus competitors' rockets, such as SpaceX's Falcon 9 Block 5 partially reusable, two-stage to-orbit, medium-lift launch vehicle, MLV. European officials defend the Ariane program, saying it provides crucial independent space access for its member states. Two variants of Ariane 6 are offered. Ariane 62, A62, with two P120C solid boosters, weighs around 530,000 kilograms, 1,170,000 pounds, at liftoff and is mainly for government and scientific missions. It can launch up to 4,500 kilograms, 9,900 pounds, into geosynchronous transfer orbit, GTO, and 10,350 kilograms, 22,820 pounds, into low Earth orbit, LEO. The first launch in 2024 used this variant. Ariane 64, A64, with 4 P120C solid boosters, has a liftoff weight of around 860,000 kilograms, 1,900,000 pounds, and is intended for commercial dual satellite launches of up to 11,500 kilograms, 25,400 pounds, into geosynchronous transfer orbit and 21,500 kilograms, 47,400 pounds, into low Earth orbit. Like Ariane 5, it will be able to launch two geosynchronous satellites together. Rocket components are transported by sea from Europe to the Guyana Space Center, French,
Centre Spatial Guyanais,
CSG, also called Europe Spaceport, aboard the
Canopée,
literal translation, canopy, a sail-assisted freighter ship that uses sails to assist with its propulsion, reducing fuel use. Additional thrust for the first stage is provided by either 2 or 4 P-120C model solid rocket boosters, known within Ariane 6 nomenclature as equipped solid rockets, ESR. Each booster contains approximately 142,000 kilograms, 313,000 pounds, of propellant and delivers up to 4,650 kilonewtons, 1,050,000 pounds force, of thrust. The P-120C engine is also used in the first stage of the upgraded Vega C launcher. By sharing motors, production volumes can be increased, lowering production costs. The first full-scale test of the ESR occurred at Kourou, French Guiana, on July 16, 2018, and the test completed successfully with thrust reaching 4,615 kilonewtons, 1,037,000 pounds force, in vacuum. The first, lower, stage of Ariane 6 is called the Lower Liquid Propulsion Module, LLPM. It is powered by a single Vulcain 2.1 engine fueled by liquid hydrogen with liquid oxygen. The LLPM is 5.4 meters, 18 feet, in diameter and contains approximately 140 metric tons, 310,000 pounds, of propellant. The second, upper, stage of Ariane 6 is called the Upper Liquid Propulsion Module, ULPM. It shares the same 5.4 meters, 18 feet, diameter as the LLPM and is also fueled by liquid hydrogen and liquid oxygen. It is powered by the Vinci engine, which delivers 180 kilonewtons, 40,000 pounds force, of thrust, burns for up to 900 seconds and is capable of up to 5 restarts. The ULPM carries about 31 metric tons, 68,000 pounds, of propellant. The Ariane Smart Transfer and Release in-orbit ship, ASTRES, was originally conceived as a kick stage to enable higher orbits for specific payloads. However, it was decided during the November 2025 ESA Council meeting to evolve ASTRES into an orbital transfer vehicle. Designed specifically for the Ariane 6 rocket, it will be an optional add-on to the upper stage and interface directly with the payload. ASTRES features a steerable main engine that can reignite multiple times to perform orbital changes, and it has 6 thrusters to perform maneuvers such as reorienting itself in space along its trajectory. This will simplify many missions by offloading some of the required built-in propulsion capabilities of payloads to move themselves to their final orbital position. For example, ASTRES could enable deep space exploration for ride-sharing payloads with destinations such as asteroids, the Moon and Mars, insert a payload directly into geostationary orbit, or augment Arianespace's ability to deploy multiple payloads such as a constellation into separate low Earth orbits on a single launch. ASTRES can also deliver satellites for a small constellation directly into their operational orbits, allowing for the satellites to be smaller and cheaper to build. Ground qualification is expected by the end of 2028, with the inaugural flight in 2029. The payload fairing, constructed by Beyond Gravity from a carbon fiber reinforced polymers, CFRPs, composite, is designed as a nose cone that splits vertically into 2 halves at the top of the Ariane 6 launch system. It is available in 2 sizes, a long 20-meter, 66 feet, version and a short 14-meter, 46 feet, version, both with a diameter of 5.4 meters, 18 feet. The interior of the cylindrical payload compartment is 4.6 meters, 15 feet, in diameter, and the long fairing variant measures 11 meters, 36 feet, in height, or 18 meters, 59 feet, when including the conical portion of the fairing. A more powerful, Block 2, version of Ariane 6 is slated to enter service in 2026, featuring enlarged P-160C solid rocket boosters and an enhanced Vinci engine in the upper stage with increased thrust of 200 kilonewtons, 45,000 pounds force. These improvements will expand the rocket's flight envelope and significantly boost its payload capacity, with an expected gain of 2 metric tons, 4,400 pounds, to low Earth orbit on the Ariane 64. Development of the P-160C boosters began in 2022. The upgraded boosters are extended by 1 meter, 3 feet 3 inches, to carry an additional 14 metric tons, 31,000 pounds, of propellant. Notably, 16 of the 18 planned Kuiper launches on Ariane 6 will incorporate this upgraded booster. The first P-160C booster casing was built in June 2024, with fueling and static fire tests anticipated in 2025. To support these more powerful rockets, CNES is assisting in modifying the existing launch pad. The first Ariane 6 launch with the P-160C is planned for second quarter 2026 in the Ariane 64 configuration. An additional Block 3 upgrade is being discussed by the European Space Agency, ArianeGroup and CNES. Increased performance will primarily be achieved via an upgraded upper stage. Phoebus, prototype of a highly optimized black upper stage, is a program to replace the metal tanks currently used with lighter linerless carbon fiber reinforced plastic tanks for Ariane 6. This offers the possibility of saving several metric tons of mass, allowing for more payload mass. A full-scale liquid oxygen model is being readied for tests in early 2026, while tests with liquid hydrogen will start in April 2026. The impetus for the upgrade is a number of upcoming lunar missions, including the European Argonaut Logistics Lunar Lander project. A decision is expected during the November 2025 European Ministerial meeting. Ariane 6 was conceived in the early 2010s to be a replacement launch vehicle for Ariane 5, and a number of concepts and high-level designs were suggested and proposed during 2012 to 2015. Development funding from several European governments was secured by early 2016, and contracts were signed to begin detailed design and the build of test articles. In 2019, the maiden orbital flight had been planned for 2020, however by May 2020, the planned initial launch date was delayed into 2021. In October 2020, the European Space Agency, ESA, formally requested an additional €230 million in funding from the countries sponsoring the project to complete development of the rocket and get the vehicle to its first test flight, which had slipped to the second quarter of 2022. By June 2021, the date had delayed to late 2022. In June 2022, a delay was announced to sometime in 2023, and by October 2022, ESA clarified that the first launch would be no earlier than the fourth quarter of 2023, while providing no public reason for the delay. In August 2023, ESA announced that the date for the first launch had slipped again to 2024. Following detailed definition studies in 2012, ESA announced in July 2013 the selection of the PPH, first stage of 3 P-145 rocket motors, second stage of 1 P-145 rocket motor, and H-32 cryogenic upper stage, configuration for Ariane 6. It would be capable of launching up to 6,500 kilograms, 14,300 pounds, to geostationary transfer orbit, with a first flight projected to be as early as 2021 to 2022. Development was projected to cost €4 billion as of May 2013. A 2014 study concluded that development cost could be reduced to about €3 billion by limiting contractors to 5 countries. While Ariane 5 rocket typically launches one large and one medium satellite at a time, the PPH proposal for Ariane 6 was intended for single payloads, with an early 2014 price estimate of approximately $95 million per launch. The SpaceX Falcon 9 Block 5 and the Chinese Long March 3B both launch smaller payloads but at lower prices, approximately $57 million and $72 million respectively as of early 2014, making the Falcon 9 Block 5 launch of a mid-size satellite competitive with the cost of the lower slot of a dual-payload Ariane 5. For lightweight all-electric satellites, Arianespace intended to use the restartable Vinci engine to deliver the satellites closer to their operational orbit than the Falcon 9 Block 5 could, thus reducing the time required to transfer to geostationary orbit by several months. In June 2014, Airbus and Safran SA surprised ESA by announcing a counter-proposal for the Ariane 6 project, a 50-50 joint venture to develop the rocket, which would also involve buying out the French government's CNES interest in Arianespace. This proposed launch system would come in 2 variants, Ariane 6.1 and Ariane 6.2. While both would use a cryogenic main stage powered by a Vulcain 2 engine and two P-145 solid boosters, Ariane 6.1 would feature a cryogenic upper stage powered by the Vinci engine and boost up to 8,500 kilograms, 18,700 pounds, to GTO, while Ariane 6.2 would use a lower-cost hypergolic upper stage powered by the Estes engine. Ariane 6.1 would have the ability to launch two electrically powered satellites at once, while Ariane 6.2 would be focused on launching government payloads. French newspaper La Tribune questioned whether Airbus Defence and Space could deliver on the promised costs for their Ariane 6 proposal, and whether Airbus and Safran Group could be trusted when they were found to be responsible for a failure of Ariane 5 Flight 517 in 2002 and a more recent 2013 failure of the M51 ballistic missile. The companies were also criticized for being unwilling to incur development risks, and asking for higher initial funding than originally planned, €2.6 billion instead of €2.3 billion. Estimated launch prices of €85 million for Ariane 6.1 and €69 million for Ariane 6.2 did not compare favorably to SpaceX offerings. During the meeting of EU ministers in Geneva on June 7, 2014, these prices were deemed too high and no agreement with manufacturers was reached. Following criticism of the Ariane 6 PPH design, France unveiled a revised Ariane 6 proposal in September 2014. This launcher would use a cryogenic main stage powered by the Vulcain 2 and upper stage powered by the Vinci but vary the number of solid boosters. With two P-120C boosters, Ariane 6 would launch up to 5,000 kilograms, 11,000 pounds, to GTO at a cost of €75 million. With 4 boosters, Ariane 6 would be able to launch 2 satellites totaling 11,000 kilograms, 24,000 pounds, to GTO at a cost of €90 million. This proposal, unlike Ariane 6 PPH, offered a scalable launcher while retaining Ariane 5's dual launch capability. The proposal also included simplification of the industrial and institutional organization along with a better and cheaper version of the Vulcain 2 engine for the main stage. Although Ariane 6 was projected to have lower estimated recurring production costs, it was projected to have a higher overall development cost owing to the need for a new, Ariane 6 dedicated, launch pad. The Italian, French, and German space ministers met on September 23, 2014, in order to plan strategy and assess the possibility for agreement on funding for the Ariane 5 successor, and in December 2014, ESA selected the Ariane 62 and Ariane 64 designs for development and funding. At the 2022 International Astronautical Congress, ArianeGroup announced the proposed Smart Upper Stage for Innovative Exploration, SUSI, a reusable upper stage for the 64, or later, variant, capable of autonomous cargo operations or carrying 5 astronauts to LEO. In November 2015, an updated design of Ariane 64 and 62 was presented, with new nose cones on the boosters, main stage diameter increased to 5.4 meters, 18 feet, and the height decreased to 60 meters, 200 feet. The basic design for Ariane 6 was finalized in January 2016 as an expendable liquid-fueled core stage plus expendable solid rocket boosters design. Development advanced into detailed design and production phases, with the first major contracts already signed. Unlike previous Ariane rockets, which are assembled and fueled vertically before being transported to the launch pad, the Ariane 6 main stages were to be assembled horizontally at the new integration hall in Les Mureaux and then transported to French Guiana, to be erected and integrated with boosters and payload. The horizontal assembly process was inspired by the Russian tradition for Soyuz and Proton launchers, which had more recently been applied to the American Delta IV and Falcon 9 Block 5 boosters, with a stated goal of having production costs. The industrial production process was completely overhauled, allowing synchronized workflow between several European production sites moving at a monthly cadence, which would enable 12 launches per year, doubling Ariane 5's yearly capacity. To further lower the price, Ariane 6 engines were to use 3D printed components. Ariane 6 was to be the first large rocket to use a laser ignition system developed by Austria's Corinthian Research Center, CTR, that was previously deployed in automotive and turbine engines. A solid-state laser offers an advantage over electrical ignition systems in that it is more flexible with regards to the location of the plasma within the combustion chamber, offers a much higher pulse power and can tolerate a wider range of fuel-air mixture ratios. Reorganization of the industry behind a new launch vehicle, leading to the creation of Airbus Safran Launchers, ASL, also started a review by the French government into tax matters, and the European Commission over a possible conflict of interest if Airbus Defence and Space, a satellite manufacturer, were to purchase launches from ASL. While development was initially slated to be substantially complete in 2019, with an initial launch in 2020, the initial launch date has slipped several times, first to 2021, then to 2022, then to 2023, and then to 2024. In October 2022, Arianespace expected the maiden flight to occur in 2023, although in December 2023, Arianespace once again set the flight to occur on June 15, 2024. In June 2024, ESA executives said its first launch was postponed to July 9, 2024. The maiden flight VA-262 took place July 9, 2024 and successfully orbited some satellites even though the mission did suffer some problems. In a January 2019 interview, Arianespace CEO Stefan Israel said that the company would require 4 more institutional launches for Ariane 6 to sign a manufacturing contract. Launch contracts would be needed for the transitional period of 2020 to 2023 when Ariane 5 will be phased out and gradually replaced by Ariane 6. The company would require European institutions to become an anchor customer for the launcher. In response, ESA representatives said the agency was working on shifting the 2022 launch of the Jupiter Icy Moons Explorer from Ariane 5 ECA to Ariane 64, further indicating that there are other institutional customers in Europe that must put their weight behind the project, such as the European Organization for the Exploitation of Meteorological Satellites, EUMETSAT, or the European Commission. As of January 2019, Arianespace had sold 3 flights of the Ariane 6 launch vehicle. 1 month later, they added a satellite internet constellation launch contract with OneWeb to utilize the maiden launch of Ariane 6 to help populate the large 600 satellite constellation. On May 6, 2019, Arianespace ordered the first production batch of 14 Ariane 6 rockets. In late 2025, the company ordered long lead time components for 27 more Ariane 6 rockets, enough for launches to 2030. In 2024, Arianespace expected that their launch tempo would increase to 6 in 2025, 8 in 2026, and stabilize at 10 per year starting in 2027. At the end of 2025, Ariane 6 had more than 30 flights booked, 4 years of activity ensured, including 18 launches for the Amazon Leo constellation of satellites. Up to 8 launches are expected for 2026. Ariane 6 was developed in a public-private partnership with the majority of the funding coming from various ESA government sources. As of 2015, the estimated government development cost over the then-planned 6-year development phase through 2020 was €2.815 billion of government-provided funds, while €400 million was reported to be industry's share. At the time, in a novel approach for ESA, this was to be an arrangement in which the Airbus Safran company takes full control of Ariane 6 design and development and commits to a firm, fixed-price contract. By the time the ESA Council approved the project in November 2016, the ESA had already paid out €688 million to Airbus Safran, and the ESA Industrial Policy Committee, IPC, released €1.7 billion of additional funds on November 8, 2016. In January 2020, the European Union, EU, institutions, the European Investment Bank, EIB, and the European Commission, loaned €100 million to Arianespace, drawing from the Horizon 2020 and Investment Plan for Europe corporate investment programs. The 10-year loan's repayment is tied to the financial success of the Ariane 6 project. The Ariane 6 rocket program has faced substantial criticism for its cost per launch and lack of reusability. When the program was approved by the European Space Agency in 2012, the program was intended to produce a modernized successor to the Ariane 5 with a focus on cost optimization. However, over the course of its more than a decade-long development, the project experienced delays and cost overruns. Initially expected to be 50% cheaper than its predecessor, the Ariane 6 now has projected launch prices exceeding €100 million per mission, above the original estimates of €70 million for the A62 and €90 million for the A64. The cost per launch has limited the rocket's appeal to commercial clients outside of Europe. A major criticism of the Ariane 6 stems from its reliance on expendable technology at a time when competitors have demonstrated the economic advantages of reusability. For example, SpaceX iteratively developed its Falcon 9 Block 5 rocket, nearly doubling its payload capacity and making it partially reusable, lowering the company's costs to launch. Some industry experts argued that the decision to forego reusability rendered the Ariane 6 already obsolete before it even entered service. European officials, however, have defended the Ariane 6 rocket, citing the strategic need for independent access to space. They point to geopolitical disruptions, such as losing access to Russian Soyuz St rockets, as evidence of the necessity for a self-reliant European capability. Officials have also justified the rocket's lack of reusability by arguing that the relatively low number of planned launches would make such a feature economically unviable. To support the program, ESA's member states have agreed to subsidize the Ariane 6 with up to €340 million annually from its 16th to its 42nd flight, expected to occur by 2031. In exchange, governments will receive an 11% discount on launches.